This is a 6.6 guided notes. We start off with the fundamental theorem of calculus part 2. And the biggest thing you guys just want to remember from this is that the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. And you're just looking at the difference between the derivative at this point, the integral at this point and the integral at b, and you're getting the difference. Think of the area model. If we're using the area model from the previous sections, then the definite integral of a function over the closed interval AB is equal to the net change or displacement in the antiderivative of f over the same interval, right? And again, if you just kind of think of the capital F of b as all the area of that integral, to the point b, and then you're subtracting capital F of a, which is the area under the integral or under the function, all the way to point A, and that gives you that middle ground, right? So again, if I was to kind of just model it real quick, right? That was a really bad line. Let me actually use these lines, make it a lot better. Here you go. So again, I have a function, right? And I have the area under this function from A to B. So if we look at the area of B, you see that it's going to be everything, all of this, right? And if you look at all the area for A, it's going to be all of this. So if we subtract B and A, you see that you just get the area under the curve from A to B. And I think that's the idea behind this theory, and I think that's the best way to look at it. All right, so let's actually look at some examples now. So we're actually going to be solving for the area under the curve for definite integrals. We're going back to definite integrals and actually getting the area, but without the area model. We're going to be doing this algebraically, right? So we're going to say that the integral of f of x ds from a to b is equal to capital F of x, and then from b to a, this is going to be our notation, and that just means to get the difference between them. So let's look at the first example. Okay. So we have a here, the integral of x squared minus 3 from 1 to 2. And again, I'm just going to apply the rules that we already have. So the integral of x squared, or the antiderivative of x squared, is going to be x cubed over 3. And the integral of a constant is just going to be that constant with the x, okay? And we're going to get this from on the interval from 1 to 2. So the way we're going to do this is we're just going to plug it in, right? This is A, this is B. So this is going to be capital B minus capital A. So capital B would be 2 cubed thirds minus 3 times 2, and then minus capital F of A, which is just going to be 1/3 minus 3. All right. And I'm not going to go over the basic algebra here, but your final answer should be negative 2/3. Right. And the biggest thing is when you're getting the minus capital F of A, make sure that you put this in parentheses so that you know that you have to distribute the negative to all the terms for capital F of A. All right, let's look at this problem here. We have the function 3 square root of x. Don't confuse it with the cube root of x. So I'm going to apply one of the properties for integrals first. And I'm going to express this as a fractional power because it's going to be a lot easier to think about the integral, right? So now I take the antiderivative of x to the 1/3, and I'm going to get, again, we're adding 1, right? So that's going to give me x to the 3 over 2 times 2/3, right? Because we're dividing by 3 over 2, but we flip it when we don't want to have 3 over 2 in the denominator alone. So by multiplying by 2/3, we bring it back up here. All right, and we're going to evaluate this from 4 to 1, or from 1 to 4 to be more precise. Again, when I plug it in, just make sure you have the 3 on the outside, and this is going to be 2 times 4 to the 3 halves. Maybe you want to express this back as the square root of 4 to the cube power over 3 minus just 1 to the 2/3, 1 to the 3 halves, which is just going to be 1 to any power is going to be 1. So this is just going to be minus 2/3. Okay. And again, after you do some algebra here, your final answer should be 14. So maybe simplify this, subtract the 2/3 since you already have thirds here, and then multiply by 3. Or you can multiply the 3, distribute the 3 right now, and it's going to cancel out the denominator. But your final answer should be 14. All right, for C, we see that we have a binomial to the second power. And I'm going to give you guys like a few seconds to think about what would be one of the tricks that we learned from the previous lesson. Okay, the best way to do this is to actually multiply this one out. And if you do that, you're going to have the integral from -1 to 1 of 4x squared minus 4x plus 1 dx. And when I take the integral, I should get 4x cubed over 3 minus 2x squared. Again, I had a 4, but remember the power is 2 and we divide by that 2. So 4 divided by 2 is 2 plus 1. And you're going from -1 to 1. And again, when you plug it in, well, I guess I'll show it. And then remember, you have to do minus, right? Minus. So this is going to become -1/3 over 3 minus 2 times -1 squared minus 1. And again, just when you simplify this, make sure that you distribute the negative to all the terms. And you should see here that this 2 is going to cancel out with this 2, and this just becomes 4/3, and this also becomes 4/3. So you're going to have 8/3 plus 2. Okay, 8/3 plus 2. And your final answer should be 14/3 after it's all said and done. All right, for actually it's probably better if I clear this all out. For D, we have a trig function, but you have your rules. It's just the opposite. So you're thinking to yourself, what derivative gives me sine? And we know that the derivative of cosine is negative sine. So our function should be negative cosine. So the integral for sine should be negative cosine, so that if you were to undo it, right, you end up getting a positive sign. So you have to have that negative in front. And plus 1 is just x. And you're evaluating this from 0 to pi, in the interval from 0 to pi. I plug in my pi, minus negative cosine of 0 plus 0. Okay, we know that the cosine of pi is negative 1. So you have a negative times a negative 1. So you end up with negative negative 1 or positive 1 plus pi. And then we know that cosine of 0 is 1. So you have negative 1 minus. So this becomes plus 1. And that's just 0, right? So your answer is going to be pi plus 2. Okay, let's look at 2 more examples. So this one, I think the easiest way to think about it is, well, first of all, let's express this as, the square root of 2 times the square root of 1 over x. Okay, or 1 over the square root of x. Like that. And if we think about it this way, then we could say, oh, well, the square root of 2 is just a coefficient. We could pull that out. We could factor that out. And we're left with this, which is just x to the negative 1/2. And I think this problem becomes a lot easier when you think about it this way. So we take the integral of x to the negative 1/2, which tells us to add by 1, right? And then we're going to divide by that n plus 1. And if it's a fraction, like we have here 1/2, you end up multiplying it. Because when you divide by 1/2, it's like multiplying by this 2. So this is going to become x to the 1/2 times 2. And we're going from 8 to 1. So I plug in the 8. And this is just going to be the square root of 8 minus 2 times the square root of 1, which is just 2. Okay, and you can simplify this out. This becomes the square root of 2. The square root of 8 is the square root of 2 over 2, or 2 radical 2, which makes it 4 radical 2. And if I multiply this out, distribute the radical 2, I will end up getting 8 minus 2 radical 2. Okay, and that's the final answer for that one. And again, the biggest difference now is that we are solving the area under the curve, or the net change in the integral from that interval. So we call these definite integrals. The other ones were indefinite, where we were just getting the antiderivative, but we weren't really applying it to a certain interval. All right, let's look at this one. Again, looking at the tricks below, looking at the tricks from the previous lesson, we're going to apply the trick here where we're going to say, hey, you know what, we have a rational function. Let's express it as 2 fractions in this case. So we would have x over the square root of x, or this would just be x to the 1 minus 1/2 power. And if we do that, we end up getting the integral from 1 to 4 of x to the 1/2 minus 2 x to the negative 1/2. And I'll let you guys try this one on your own. I'm not going to show it, but your final answer is going to be 2/3. Right? And don't forget to distribute that negative when you're taking the net change between B and A, right? Make sure that you distribute that negative to all the terms under capital F of A.